All right, we're going to start our NDSU Rocks walking tour here inside the library on the main campus. This green rock that we're looking at is a metamorphic rock. It's marble, and this particular rock was quarried in Vermont and brought here to be used as a decorative stone. All right, stop 2 is outside of the library. The rock that we're looking at here between the windows is a metamorphic rock called a gneiss. We know where the name of this particular gneiss is the Morton gneiss. And this is really a very high pressure, high temperature metamorphism, because there are areas within this that have almost completely melted, but yet the rest of it remains solid, and you can see the sort of warping and twisting that the rock was enduring under that high temperature and high pressure. All right, we're outside of Putnam Hall. We're at a monument to a gentleman named Bjornson. I do not actually know the history of this one. I'm guessing an early president of the university or a donor back in the earlier days of the university. But what we're here to see is the granite that this monument is made out of. It's a igneous rock and a pretty straightforward granite with the pinkish or tannish potassium feldspar and clear or white quartz and a few ferromagnesian minerals. It's pretty straightforward granite. Okay, stop number 4. We're outside of Old Main, on the south side of Old Main, and many of the older buildings on campus have this red sandstone as part of their trim or decorative elements. And this is a fluvial sandstone, a sandstone that would have been deposited in a river. And over here is a great example of cross bedding. You can see there's some layers down here sloping, and then a fresh set of layers cuts across that, and new bedding planes are shown. So that's a great example of what we call cross bedding. That can happen in wind or water, but the reason I'm sure this is river deposited, you can see in this block down here. It's a great example of fluctuating flow velocity in the river. At times there's enough energy to transport these pebbles, and then they get deposited, and then at other times it's just mostly sand. So that's changing flow velocity that happens within a river system. Okay, we are now on the south side of South Engineering, or the physics building. Some of the decorative components on this building, the ones that we're looking at right now, and the columns as well, are different from the red sandstone that we saw on Old Main. This is a sandstone called Duluth Brown. They know where it was quarried. Sandstones are sedimentary rocks. I don't think I mentioned that at the previous stop, but sandstones are sedimentary. And as I said, they know where this was quarried, but unfortunately that area that had this dark brown sandstone has been completely quarried out. So newer buildings can't even use this particular product. We're now inside the doorway to the physics building, and we're looking at the trim just above the floorboards. Several of the older buildings have this reddish lime marble that makes up this trim element. It's really distinctive because of the coloration and the banding that you can see in it. And it is a marble, so it started out as limestone, which contains calcite. And so I didn't want to do it over at the library, but we can put a little bit of acid on that and see that it foams, indicating that it's made of calcite. And I don't know the name or origin of this, but you find it in a lot of the older buildings on campus. So we are now between Menard Hall, the library, and the physics building, and there is a memorial here for Herbert Albrecht, and we know that he was a former president of the university. The rock that this plaque is on is a diorite, a igneous rock, and so it's an intrusive version of andesite, and it's kind of dirty, but this is a fresh-ish surface down here. So you can see it has a fairly moderate to high proportion of the ferromagnesian minerals, the dark minerals, making it a diorite. And another really interesting aspect of this rock that we have here are these black bands that you can see. And so these are chunks of the rock that the diorite was intruding into. The rock that was in place, some of it would be melted, but some of it breaks up and gets incorporated into the magma before it crystallizes. So those are called country rock, or sometimes called xenoliths. But a nice example of diorite, and interesting that it has these xenoliths. All right, we are at the fountain on the north side of the physics building, or the little stream area, looking at a memorial for Orville Edom. And the rock that's carved into is the Sioux Falls quartzite. It's a metamorphic rock. Essentially one mineral, although it does have some iron oxides in with the quartz. Pretty high grade of metamorphism, and it produces a really hard, durable rock. All the rocks, decorative rocks that you see in through the fountain are made of this Sioux Falls quartzite, and it does come from the area around Sioux Falls. And I think I said metamorphic, but I'll say it again. Okay, we are on the south side of Ladd Hall, the chemistry building. Some people may refer to it as the chemistry building. We're looking at the steps coming out, and we have this kind of tan beige colored sandstone. Different from the others we've seen, but it is a sandstone, so it's a sedimentary rock. And you can see there's some evidence of cross bedding up there as well. So most likely laid down in a river. This is possibly a beach environment. We know this is Cambrian age from some notes that were available in our department, but we don't know the specific location that it came from. Okay, we are outside of Shepherd Arena, and we are looking at the a plaque commemorating the achievement of Golden Marguerite. This is one of my favorite, or is my favorite rock on campus. But before we go into that, I want to show you another stone up here. So many of the buildings around campus have this grainy white stone, natural stone, as a decorative element. This is a sedimentary rock. Thomas, if you can zoom in, you can actually see some fossils in there. That's one, that's one. And in fact, most of these things are broken bits of fossils that we can't really recognize. And this rock is sedimentary, and it's called limestone. And again, it's made out of calcite. So what will happen? It will react with the weak acid. We looked at a marble and a couple marbles earlier. So this would be the sedimentary rock that marbles, the kind of sedimentary rock that marble forms from. Okay, let's go back and talk about Marguerite's rock. So why do I like this rock? Well, the first reason is there aren't many memorials to dairy cattle around the country, I don't think. It's on a very nice, straightforward piece of granite with the basic recipe of pink or tan feldspar, quartz, and darker ferromagnesian minerals. But the other thing that makes this my favorite is Golden Marguerite's rock was dragged at the bottom of a glacier. If you come around the back, and there he goes, he's petting a rock. If you come around the back, it's been smoothed out because it was dragged underneath a glacier as it was transported down here from Canada. So a good example of igneous granite, and it has some what we call glacial polish, evidence of glacial transport. Okay, so here's a challenge. I want you guys to be rock petters. Come out here and take a picture of yourself petting the rock and send it to me, email it to me. There's your challenge. Okay, so another reason why this rock is my favorite is there's a whole legend connected to this rock. And when the legend, urban legend is when Golden Marguerite died, they wanted to bury her on campus. And at the time, the building that was torn down, or was torn down, where they're making the new chemistry and geology building, there was a little brown building there called the Dairy Building. And the legend was that she was buried out on the west side of the Dairy Building, and this rock used to be in front of that building. Obviously it was a dairy, and so the legend was that this rock was marking her burial. But many attempts to find that grave were made over the years, and then when they did the excavating for the new building, there was no evidence of a burial at all. It's usually fairly easy to see disturbance in the soil if something's been buried, especially something as large as a cow, and they didn't find any evidence for that. But it was a fun story, all related to this nice rock here. A rock like this in nature that has some weathering on it, if you can find a broken surface, it's easier to tell what you have. And this is a straightforward granite again, but in this case, rather than the tan or pink feldspars, we basically have a white feldspar. So we talked about the recipe for a chocolate chip cookie. It could be white chocolate, it could be dark chocolate, so it's just a variation in the kind of feldspar. I also think Herbert's rock may have been eroded by a glacier, but it just doesn't have the same polish as Golden Marguerite's. Okay, the last land stop on the walking tour is further further north on Albrecht. So we're not going to walk that, but you'll see the rock image will be edited into the video. Okay, last stop on the NDSU Rocks Walk. We're in front of the Agricultural Research Center building. There's numerous buildings, but this is the one up on Albrecht, north of the baseball stadium. We came here to look at this ornamental stone that's surrounds their doorway and their sign out in front of the building. And this is a gabbro, so it's a coarse-grained, intrusive mafic rock. But what I brought you out here to see is you can see a blue sheen on some of these minerals. So that is a type of plagioclase feldspar that's called labradorite, because it was first found in Labrador. But the feldspars in the rock have twinning on the atomic scale. We call it twinning, where it creates a fine grid at the atomic level, and that grid refracts light, and that's why it has the shimmering blue reflective appearance. There are nice examples of this, are often made into jewelry and things like that. All right, so I hope you enjoyed the walk and learned about NDSU and some of the great rocks. Yay! All right, we'll call this a bonus stop. It didn't fit in real nice with the walking path, but we're in front of the engineering building and we're looking at the Tau Beta Pi key statue, and that statue is on a nice bit of white granite. So most of the granites we've seen have the pink or tan feldspar. This one has the white feldspar, albite, and so both granites, or all of those are granites, but this one has a slightly different type of feldspar in it.